social scientists, like natural scientists, look for regularities that explain puzzles. They are much less successful for many reasons, one of which is the number of variables potentially affecting the outcome and the difficulty of controlling for them. So what are the GMO puzzles? We'll begin with one puzzle. Why has agricultural genetic engineering been far more controversial than in pharmaceuticals, medicine, or industry, where recombinant DNA work is quite accepted and not in a special category? Indeed, the only things called GMOs are agricultural crops. And we pointed out some reasons that people are especially worried about GMOs and why they oppose them. Secondly, there's a larger puzzle within agriculture. Why has acceptance of new crop technology from the so-called gene revolution, that is GMOs, been so much more controversial than the green revolution? During the green revolution of the 1960s, 1970s, newly available varieties of wheat and rice developed through conventional plant breeding were taken up rapidly by farmers, both large and small, particularly in Asia. Between 1966 and 1998, the percentage of crop area in Asia, including China, planted to modern varieties increased to 82%. Improved rice varieties originally developed by the International Rice Research Institute eventually were released to more than 70 countries. One consequence is an enormous increase in yields and productivity across these crops. The gene revolution in agriculture was quite different from the green revolution. Why is that? Our study of the objections to GMOs gives clues to explain this difference. First, green revolution crops were developed in not-for-profit international scientific institutions. Patents did not constitute grounds for concern. It was impossible to think that everything is owned by Monsanto. Second, social mobilization around the environment and opposition to corporate globalization were not really developed in the time of the Green Revolution. The transnational advocacy networks that are so powerful in opposition to GMOs, such as Greenpeace, had not yet formed. These clues help us understand answers to this module's question: why does acceptance and rejection of GMOs differ so much across countries? First thing one notes is the absence of any single dimension of the global rift. Unlike many sources of difference in the international system, these variations do not follow a north versus south pattern or developed versus underdeveloped pattern, nor democratic versus authoritarian. After the United States, for example, the next 5 countries in the world ranked by area planted to GMOs are Brazil, Argentina, India, Canada, and China, in that order. And of course, many countries have no GMOs whatsoever, at least not officially. We've already seen an illustration of one important variable in the papaya case in Thailand. Greenpeace and local allies proved able to defeat government science on the safety and the efficacy of the virus-resistant papaya developed by public sector universities and collaborating scientists in Thailand, in the government in particular. There was no Monsanto in the picture, but the virus-resistant papaya was blocked. The general cause in this case is transnational advocacy networks and local allies. This effect was apparent as well in India in the BT brinjal or eggplant case. The Prime Minister, as well as a secret report from the Home Ministry in India, accused non-governmental organizations, that is NGOs, with foreign funding of blocking India's development by opposing biotechnology. As a result, Greenpeace and many NGOs have been subsequently restricted by the government. The conclusion is just that social mobilization of opposition varies over time and space, and the coalitions that involve opposition are fluid. Consumer groups, for example, often in coalition with anti-corporate and environmental groups, have also been influential in many countries, including France and Japan in the early years. Often joining this coalition are the natural foods industry and Organic Products Association and organic farmers. Export markets have mattered. After the turnaround in EU policy in 1998 from support for agricultural biotechnology to a moratorium on GMO imports, many countries and farmers around the world became more cautious about biotechnology. Sensitivity varies by the export basket of the country. Thailand, for example, does not export a lot of papaya, so this was not a consideration in regards to the GM papaya. But for Brazil, it could be a big consideration in rejecting the virus-resistant papaya since it exports to Europe. Mexico's consideration of a papaya export industry would be more influenced by the American market, where GMOs are accepted, including a transgenic papaya, than by the EU market. Worries about markets for export crops was an issue in Southeast Asia in the early years of the gene revolution. These concerns have been important in delaying development of biotechnology in Africa as well. Third factor is the scientific and technological capacity of the country. China and Brazil both had scientific capacity that was quite significant to develop their own biotechnology on their own terms with their own public sector institutions, utilizing global technology advances as well as collaboration in some cases with multinational firms. Countries that lack this capability, this capacity, are more likely to worry about dependency relations and foreign control and are less likely to be major adopters of GMOs. Fourth, there are differences in farmer demand and organization. The GM crops so important to American farmers, cotton, maize, soybeans, are much less important to European farmers, as well as to farmers in many other countries. The political weight of farmer groups can play an important role for or against adoption of GMOs. Finally, there is the big question of regulation. How is regulatory authority structured into the national government? There are many options. This is important because biosafety institutions provide choke points through which GM crops, but only GM crops, must pass. Who controls these choke points? One important difference is the location of state science in particular parts of government. We've seen, for example, around the world, more resistance from institutions dominated by ministries of environment than those dominated by ministries of agriculture. You can really imagine the reasons for this difference. Departments of agriculture are keyed to benefits, improving agriculture and farmers' well-beings, and responding to their interest. Their constituency is likely to be pro-GMO. Environment ministries or departments, on the other hand, are more oriented to risk than utility. And they're used to unknown unknowns and complex ecological dynamics. Taking a precautionary approach is more in keeping with their mission and their ethos, and more politically astute. Their power base is not in farmers, but in environmental NGOs and transnational advocacy networks. We can see the difference in approval and rejection of a GM eggplant between India and Bangladesh in recent years. It's an interesting contrast because both nations develop public sector varieties for seed saving, and they use the same Bt transgene, the Cry1AC, in an event developed in India. The Indian eggplant, Bt brinjal, passed 9 years of government scientific tests and field trials, but was rejected by the Minister of Environment in 2010 on grounds that not enough testing had been done, not all risk had been eliminated. The Indian cabinet split on this issue. The ministers of agriculture and science and technology, and indeed the prime minister, were convinced by the scientific consensus. But statutory authority lay with the Minister of Environment. The structure of India's biosafety regime thus enabled what political scientists call a veto player, the Minister of Environment, whose stance was explicitly precautionary. He rejected Bt eggplant. Neighboring Bangladesh used the donated gene developed in India to develop 4 varieties of Bt brinjal in the same period, with power lodged in the Agriculture Ministry and its institutions. Those varieties were approved in 2014 and are now growing in farmers' fields in Bangladesh. Most people who know agriculture in India expect brinjal seeds harvested from these crops to sneak across the border and establish themselves in India. Many people believe they're already there, but we don't have any firm evidence yet. There are many other variables of importance in explaining acceptance, rejection of GMOs across different countries, including mobilization of science and science communication in civil society and politics, as we explore in other sections of this course.